Welcome back to Hypothesis Testing Done Right, Part 10 of 14. In Part 9, we hammered home what the p-value is not, including that it is never the probability the null is true. A p-value answers one question: can I reject this particular null? Now we meet an object that answers all of them at once, and is often the more honest thing to report, the confidence interval. Start from the test. We fail to reject the candidate null value mu0 at level alpha exactly when the statistic is not extreme, when the absolute value of t is at most t star, the two-sided critical value. Writing that inequality out and rearranging, x bar minus t star times the standard error is at most mu0, which is at most x bar plus t star times the standard error. The set of all null values mu0 that survive the test is precisely the interval x bar plus or minus t star times the estimated standard error. That is the 95% confidence interval. So a confidence interval is simply the collection of null hypotheses you cannot reject. A test inverted. For Sam, with t star about 1.97 at 251 degrees of freedom, the 95% interval is 8 basis points, plus or minus 1.97 times 0.0473%, which works out to roughly negative 0.013% up to positive 0.173%. Two things to read off Sam's interval. First, 0 is inside this two-sided 95% interval, consistent with the fact that Sam's one-sided test only barely cleared its bar and a two-sided test at 5% would not reject. Second, the interval shows the full range of edges compatible with the data, from a tiny loss to a sizable 0.17% daily gain. That range is wide, and its width is the standard error scaled up, the honest measure of how little 252 days really pin down. Now the interpretation of confidence, which deserves the same care as the p-value. The correct statement is about the procedure. If we repeated the whole experiment many times, 95% of the interval so constructed would contain the true mu. It is not correct to say there is a 95% probability that mu lies in this particular interval. Once computed, the interval either contains mu or it does not. The 95% describes the long-run hit rate of the method, not the realized interval. Same logic as before, mu is fixed, and the interval is the random thing. To summarize Part 10, a confidence interval is a hypothesis test turned inside out, the whole family of null values you cannot reject, written as the estimate, plus or minus t star times the standard error. For Sam, the 95% interval runs from a small loss to a sizable gain and contains 0, telling the same story as the marginal one-sided test. Its width is the honest measure of how little a single year of data pins down. And the 95% is a property of the method's long-run hit rate, not a probability about this one realized interval. Nu is fixed, the interval is random. In Part 11, we confront a scenario that should bother you: how a result can be wildly statistically significant and yet completely worthless. That is the gap between statistical significance and effect size.